Welcome to Chapter 12, which is the post hoc and the planned comparison. So the first question that we end up asking is, why do we need the post hoc analysis after ANOVA? So when we are talking about doing ANOVA, that means we are talking about one-way ANOVA. So when we do the ANOVA, we assume that the means across the different populations would be the same. That means there is no variance, like mu1 is equals to mu2 is equals to mu3. But when we reject the null hypothesis, that means we accept the alternate hypothesis that those means are not equal. We just know that there is a statistical difference, that the means are not equal, but we don't have any other information about it. For example, we do not know whether the mu1, like the sample mean from the sample extracted from the population 1, has a higher mean than the other two, or if two are equal and one is not equal. We have no further insight on it. That is why post hoc analysis is done. So on your page 257, there are two classes of procedures that are considered, the post hoc comparison and the planned comparison. The post hoc comparisons were developed because a one-way ANOVA F, if significant, does not provide any specific insight into what caused the null hypothesis to be rejected. Yes, the null hypothesis is rejected, but I don't have any insight on it. Like all the population means are probably not equal to one another is helpful. Yes, that is what we wanted to find out. But what is the different scenarios? Maybe two of them are equal. If we are comparing three comparison groups, 2 mu can be equal and a third one could be higher, or maybe a third one could be lower and all of the three could be different. So the post hoc analysis helps you probe into the data to find out which of the possible non-null scenarios is most likely to happen. So that is why you need the post hoc analysis. And so the planned comparisons are also another inferential procedure that is developed by the researchers once again to figure out questions that cannot be answered by just rejecting the null or failing to reject the null hypothesis in the one-way ANOVA. For example, the different pair of mu's are like if the average of the different two mu's is different than the third one, or of all of them are different, or what is the case. Okay. So the next thing that we are going to talk about is how to do it or what it is. So let us take an example to help us with the post hoc comparison. There are various terminology that is used with the post hoc analysis. It is obviously called a post hoc test. It could also be called a follow-up test, a multiple comparison test, or a post priori test. So if we have a question, if we have an experiment in which we want to examine the safety of the compact cars, the mid-size cars, and the full-size cars. So here, what is our independent variable? Our independent variable is the type of the car, whether it is compact, mid-size, and full-size. So it is one independent variable, and there are three groups that we have. We collect a sample of 15 for each of the treatments. That means each of the car types has 15. So our total sample is going to be 45. We have the hypothetical data below because we are looking at the pressure applied. What is the level of significance the researcher is choosing? It is 5% or 0.05. Remember how chapter 7 talked about that you have to choose your level of significance before you begin your study. So this is my data that I have. So the assumptions, once again, we are coming back to the assumptions for ANOVA. we talk about our n. Our n is 45. That means it is greater than 30, which is basically the assumption for normality. If we do the histogram, we have this is for the compact cars, this is for the mid-size, this is for the full. So essentially they are following a normal distribution curve. So that means the assumption for normality is met. I also did one of the tests for normality. You don't have to worry about that how the test was done, but if this test is called the KS test of normality. Here is the test name, the full form of it. So we have a null hypothesis that says that it follows a normal distribution. Like these three follow a normal distribution, and the alternate hypothesis says it does not follow a normal distribution. So if you look at the p-value, it is 0.2, 0.2 and 0.2, which means it is greater than 0.05, and we cannot reject our null. So we fail to reject our null, which essentially means that it follows a normal distribution and satisfies the normality assumption for ANOVA. So this is satisfied, a normality assumption is satisfied. The second one is a dependent variable is at least in the interval level. Yes, they are the ratio level so that we can do the statistics on it. Once again, there were 4 levels of data that was there: ordinal, nominal, interval and ratio. There were 4 levels of data when we were talking about. The categorical or nominal were just giving values to any, like if you talk about hair color, black, blue, green, so the values were given 1, 2, 3, that is nominal data, just giving them values. But if there are ordered or ranked data, then that is called the ordinal level. And then we have the last 2 levels, that is called the interval level and the ratio level. Ours is the ratio level. If you want to read more about this, I actually have uploaded an article. Here is this article that you guys can, and it will be in your D2L also. This article gives you more on the theory of measurement by Stevens. And here is the 4 types, is nominal, ordinal, interval and ratio. When we had talked about correlation also, we had talked about the different types of correlations can be done depend on the different types of data that you have. So this is where we have to, most of the mean, standard deviation, the correlation and all those things can happen on the interval and the ratio data. And ours is the ratio data. So we have the normality assumption, the dependent variable assumption. We have the homogeneity assumption again with the same way that we are talking about. Once again, this is the test for homogeneity. And so we fail to reject the null in the same way. So that means that they do have homogeneity of variance is met. And then dependent variable has independent value. Yes. So all the assumptions for ANOVA is met. So we go ahead and do the ANOVA. When we finish doing the ANOVA, this is the table that we get. Remember how in chapter 11 we talked about interpreting this table. All these chapters 10, 11 and 12 are very much built upon each other. So that is why I keep referring to those chapters. So this is a mean square, this is a sum of square, this is a degrees of freedom. If we add 1 to 2, that gives you 3, which is that tells you there are 3 groups in it. If we add 1 to the total, or if we add these two and add 1, that gives you 45, which is your total number of data points. And then this is my F value, which is very large, and you can see the P significance is less than 0.000, which means we reject the null that there is no statistical difference between the three cars. There is some statistical difference. That means the mean pressure applied to the driver's head during crash while driving a particular type of car in the whole population is different for the three different types of cars. There is some statistical difference there. So this is what we've done with ANOVA. So we know there is a statistical difference, right? So maybe the compact and mid-size means are equal, but it is different than the full-size mean. Or maybe the compact and full-size means are equal and the mid-size is different. Or maybe the mid-size and the full-size means are equal and the compact is different. Or maybe all the means are different. So there are four different scenarios here, but we do not know which one is true. Hence, we will perform a post hoc comparison to find out which one of these is true. Here is a variety of post hoc analysis that you have. This is a table or a screenshot from SPSS. You don't have to do SPSS. You do not need to know about each and every one of them as to what is done specifically in every one of them. But you want to know about the different ones that are there. There are common ones. Bonferrari is common one. Schaeffel is common one. We have a Tukey that is a common one. So those are common ones that are being done. Your assignment 5 talks about what post hoc analysis is done in the paper. So you do not have to explain the post hoc analysis. You just have to go find out which one is done and put the name in. So it's like a one-word answer. And I think there are about 2 questions to 3 questions that just ask you is what post hoc analysis is done. It again asks you why a post hoc analysis is done. So that is another thing that you just have to talk about as to why it is done. In the sense that was the null rejected or not failed to reject, or what does the researcher want to do in terms of that. Here you can see that the level of significance, I'm going to minimize this a little bit. The level of significance is 0.05, that is again 95%. Stephens, that is the one of the big statisticians, suggests that Tukey post hoc is more suitable post hoc than others looking at the various aspects. So now let us talk about planned comparison. So the planned comparison is basically about a researcher might choose to compare the different variables without conducting a basic ANOVA test. In this chapter, we are not going to cover planned comparison in depth, but I just wanted to give you a mention of what the planned comparison is. But what we really do want to look is at the results of a post hoc investigation. So if you look at page number 264 and 265, the excerpts 12.12 and 12.13, you're going to see that there was a one-way ANOVA done that shows statistical difference. We had 3 groups and we had 55 in total, and a post hoc Tukey test was conducted to show that heavy metal music condition had significantly higher scores than the classical and the pop music. So I had 3 groups, classical, pop and metal music, but when I did the post hoc, I saw that the heavy metal music was significantly more. The same way 12.13 talks about one-way ANOVA gives me a statistical difference in 4 groups. So I have 4 groups here. But when I do the post hoc analysis, in this case, there was a bond-free analysis to explore the differences among the 4 CLPB groups. So here, see, they're actually giving you a justification also. And then you see that there was a statistical difference between group 4 and group 3 than the others. So that is why a post hoc analysis is done. This is basically what you need to know about chapter 12. I hope I have made it simple to understand and to follow as to what we are talking about. Um, if we even look at the excerpts 12.1 and 12.3, if you will see that they give it different name: post-doc, multiple comparison, follow-up test, but they all mean the same thing. This is all, and if you have any questions, please don't hesitate to ask. Best of luck, guys.